Why, hello friends! Jen Foxbot here for another edition of Math Mondays. Yeah! Alright, thanks for joining me. In this episode, we are going to do a review of Algebra I. So I'm going to give you 4 different problems, and the challenge is to solve them. So the best way to get good at these types of things is to practice. Just like when you learn a foreign language, the best way to really understand a foreign language is to practice it. Practice reading, speaking, and writing. Same exact thing with mathematics, because mathematics is just a language. So these are just 4 example problems that cover the big picture concepts of Algebra I. A lot of what we learn in Algebra I are tools and tricks to be able to solve different types of equations. I will run through each of the problems that I give you, but I challenge you to do them on your own first, and then watch the video as I run through them and check your work to make sure that it is similar to mine, or at least that the thought process is the same and that we get the same answer together. Cool. All right, so first I will start by giving you all 4 problems by writing them out in different colors, because I finally have colored chalk. Yay! And then I will go through the problems in order. All right, so here we go. So the first problem is 12a times 3b minus b divided by 4a equals 36. That is your green level problem. Next is your blue level problem, which is, this one I'll check my notes for, 2 squared minus 2x divided by root 2 equals 1. Okay, orange level problem, here we go. X squared minus 10x plus 25 equals 0. And last but certainly not least is the pink level problem, or red, kind of reddish pink, very pretty color. 2x squared plus 6x equals 3x plus 2. All right. So, wow, my handwriting slopes on down to the left, but hopefully y'all can read those. So I'm going to take a second to let you write it down, or of course you can, use the computer and pause the video, write them down, and then run through them on your own. If you're a little intimidated, that's totally fine. You can watch it and we'll go through it together, and then you can go back and solve these without watching the video, and then double check that your answers are the same. And if you get it wrong, that's totally okay. Just repeat the process, identify where you went wrong and why, and then use that to correct your thinking the next time around. And then you just repeat this process until you understand the different steps and until it kind of clicks in your brain. Okay. So let's solve the green problem first. Okay, so in this problem, your first reaction, hopefully, is, wait, there are 2 variables, A and B, and we don't have any information about those variables. That is an excellent first thought, because that should worry you. Right off the bat, my initial reaction is, wait a second, there are 2 unknowns and only 1 equation. Typically, if you have 2 unknowns, you need 2 equations to solve them, because you would solve for 1 variable in terms of the other. So say, for example, this is not the case here, but let's say you got b equals 2a, then you would use that and plug it in to the second equation, and then you can solve for both variables. In this case, we only have 1 equation, so something's got to give. If you see an equation like this on the test and it doesn't resolve itself, your teacher will usually ask you to write one variable in terms of the other. And that just means, oh, I got a little blurry. That just means that they want you to give, say, variable A with B in your answer. Okay, so that being said, let's go ahead and tackle this. So the first thing we can do is we can simplify this 3b minus b. So let's do that. So we get 12a times 2b, and I'm also going to pull out this 4a. And the reason I can do that is because 12a is multiplied by the term in the parentheses. So when you have multiplication, you can move things around, and that's okay. All right, and then this equals 36. Okay, so now you'll notice, boop, our variables can cancel. That's great, because now we only have one unknown in our equation, which means we can actually solve for it. This is kind of a weird example. In algebra, this is totally acceptable. In higher level mathematics, your teacher might expect you to do a little bit of analysis of what this means. But here I'm just going to, it's going to suffice to say a divided by a equals 1, and so you can get rid of a. And so now 12 divided by 4 is 3. So we have a remaining 3 times 2b equals 36. And since we're solving for b, I want to divide both sides by 3, which gives me 2b equals 12. Ooh, we're getting close. And now we divide both sides by 2, and we get b equals 6. All right, not so bad. Cool, so that is our green problem, where we're dealing with a little bit of a tricky situation with two variables. Okay. Onward to the blue problem. Okay, so problem number 2 is 2 squared minus 2x over root 2 equals 1. Ah, we have a radical or a square root in our equation. We haven't really looked at those, but don't worry. We can treat square root of 2 just like we can with other numbers. The first thing we want to do is simplify this exponent. So we get 4 minus 2x divided by root 2 equals 1. And now I want to, personally, my preference is to get x by itself right away. So I like to pull out numbers from the parentheses if I can. And in this situation, I can, because the number 2 is common in both of these numbers, which means I can pull a 2 out of the parentheses. So I get 2 times 2 minus x. And so if this is confusing, think about it this way. Think about it the opposite way. What happens when I multiply 2 by both of these terms, or if I distribute the 2 to both terms? So in this case, I would get 2 times 2 is 4, and 2 times negative 1 is negative 2. So when you do this, and you're first getting started, it can help to double check your step by just making sure that you have kept things the same. This is one of those tricks where you're just rewriting the equation so that you can simplify it. Okay, and so now we still have a square root of 2 in the bottom equals 1. And now I want to start isolating or getting x by itself. So let's do that by multiplying both sides by square root 2. Oh, wait, multiply. And so now I get 2 times 2 minus x equals root 2. And now I want to divide to get this 2 out of the way. And I get 2 minus x equals root 2 over 2. And here's when I've run out of space. So I'm going to erase this part. Okay. I'll draw a little line there to let us know that we're going like that. Okay, so now I'm going to rewrite the equation. 2 minus x equals root 2 over 2. Okay, so now I can kind of drop the parentheses and I can subtract, oops, yeah, I'll do it over here, 2 from both sides, which will cancel this 2, and we'll get negative x equals root 2 over 2 minus 2. A lot of 2's floating around. And now we have this negative 1 out front of the x, which makes my x have a term that I don't need. So we will multiply both sides by negative 1. And that effectively will flip the sign on each of these terms. So we get x equals positive 2 minus root 2 over 2. And if your teacher has not asked you to simplify this expression anymore, that's it. You can leave it there. We have x by itself, and we have numbers on the right side. And so with a calculator, we can actually figure out the exact number of x. A lot of teachers are like, cool, that's good. Especially as you get into higher level math, that is an acceptable answer. When you're just learning how to do algebra, a lot of times your teacher will ask you to combine terms, so making sure that you only have one fraction or something like that. There are many ways to simplify this. I'll show you the easiest way. So the easiest way to do this is to get the same common denominator. And to do that, since right now we have a 2 over 1, we want to get a 2 on the bottom of this fraction. And to do that, we are going to need to multiply 2 over 1 by 2 over 2. A fancy way of writing 1. And that would give us 4 over 2 minus root 2 over 2, which is just 4 minus root 2 over 2. And that is likely how your teacher will want you to simplify it. The other thing that I want to show you, which I'll do down here, is that when you're dealing with radicals or square roots, there are many ways to simplify them that are not super intuitive. So for example, let's say you have root 2 over 2. Another way to write this is to recognize that you can write 2 as the square root of 4. It's the same thing, it's just a different way of writing the number 2. And now you can actually combine this fraction, which allows you to sort of simplify it. Simplify might not be the correct term. It's more just you're rewriting the square root in a different way. And what you can do in this situation is you can actually reduce that to 1/2. And now you have the square root of 1, which is just 1. So you get 1 over root 2. And so I want to be clear that this is equal to this. And I challenge you to double check that. So this is my claim. Plug both of those fractions into a calculator and make sure that they're equivalent. And then think about why that is true. Okay, so that was our blue problem. And nope, we're on number 3. We don't have our last problem yet. But this is our orange problem, yay! Okay, problem number 3 was x squared minus 10x plus 25 equals 0. All right, so this is a problem where once you've done a few of these, you'll recognize, oh, I can factor this one. So I'm a huge proponent of the quadratic equation because it will work every time when you have a polynomial of order 2. But if you can factor quickly in your head, it is much more efficient in terms of your time. So if you're doing a test and you want to solve things really quick, factoring can be a really good way to do that if it's obvious. If not, just use the quadratic equation and you'll get the same answer. In this case, I recognize that 25 is a perfect square, which means that 25 is the square, or 5 times 5 is 25. The square root of 25 is 5. And so that tells me And I also know that -5 plus -5 is -10. And so that tells me that x minus 5 times x minus 5 is a way to factor this equation. And then you just get x minus 5 squared equals 0. So then you would just say x1 and 2 equal 5. Boop. A little faster than doing the quadratic equation. But yeah, pretty straightforward. And of course, with all of these, double check my work. Okay, now we're on to the last problem, which is, okay, 2x squared plus 6x equals 3x plus 2. Okay, so the first thing that I want you to recognize with this problem is that you can't solve it, well, you can't really solve it easily until you have a 0 on the right side. So the first thing to do is to move all of these terms on the right side of the equation over to the left side. So to do that, we subtract 3x on both sides, and we subtract 2 on both sides, which gives us 2x squared plus 6x minus 3x minus 2 equals 0. These two terms have one x in them, so we can combine them. 2x squared plus 3x minus 2 equals 0. And now we breathe a sigh of relief because we're like, all right, this is in the form that we can use for the quadratic equation. All right, so now we get x equals minus b plus or minus square root b squared minus 4ac divided by 2a. So remember, that is a, that is b, and that is c. Okay, so now we can simplify. X equals -3 plus or minus root 9 minus 4 times 2 is 8. 8 times -2 is positive 16. So we get 9 plus 16, which is good because we haven't dealt with complex numbers yet, divided by 4. Okay, and now I'm going to come back up top. I'll give myself a little more space. Okay, x equals -3 plus or minus square root 9 plus 16 is 25. And we breathe another sigh of relief because we don't need our calculators for this one. And so we get -3, equals -3 plus or minus 5 over 4. So now we say x1 equals -3 plus 5 over 4, which is just 2 over 4, which is 1/2. And I need some more space. All right, and then we get x2 equals -3 minus 5 over 4, which gives us -8 over 4, or -2. So x1 equals 1/2, x2 equals -2. Boom, not so bad. All right, that's it, my friends. So each of those examples incorporates different skills throughout algebra. I didn't cover all of them, so the more practice problems you do, the easier it'll get and the more you'll be a algebra wizard. All right, like in general, please let me know if you have any questions on any of the things that we did in this Algebra 1 review. If there are any steps that were unclear, or if there's any part of my logic that you're like, wait, what? Could you explain that a little bit further? Happy to do so. And of course, please let me know if you have any questions about algebra or other math topics in general. All right, good luck with algebra. You got this. Just practice, 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 and you'll be an expert in no time. All right, thanks very much, and we'll see you next time. Bye!